This is CIS30A Week 2 Part 3 lecture. In this part, I will cover control statement. We will go over if-else, nested if-ELIF, and for loop, while loop, break, and continue. So to begin, we're going to talk about if statement. And we use control statement quite a bit to apply conditions. We can use conditions earlier, like I mentioned, to check for input validation. If the user input the correct content, we would move them forward to the next field in the form. If they don't, we would prompt them to re-enter the information. Or if certain value is true, then we can operate certain calculation in our program. So we would use quite a bit the control statements to be able to apply conditions in our program. So the first is the if statement. And the if statement would involve checking the test expression following the keyword if. So when you write an if statement in Python, you would start with if and then give it a test expression. After that test expression, you have to put in a colon, and then the following statements needs to be in the indented line following. Otherwise, it would give you the error. So as we look at this diagram, if we can see how the program would be branching. First, it's going to check for the test expression. It must be true for the if statement. If it's true, then it would execute the body of if, the following statement in the body of that if statement. If it's false, it's going to exit out of that block. It would not be able to execute the body of if. So let's take a look at this example. We have a variable called num, and we assign it 3. Then to start our if statement, we would say if num is greater than 0. In this case, it's going to check, is 3 greater than 0? Yes, that will be true. Then it's going to go in and it's going to print this. It's going to execute this process right here. This operation would take place because it's true. So it would print num is a positive number. And then after that, it would go to the next line. This is always printed. But in the case where num is not greater than 0, let's say if we give it a negative 3, then it's going to skip this. It's going to go directly to the last line. Print. This is always printed. It's going to completely skip the body of the if, because if it's negative 3, then this test expression is not true. As you can see here in the second part of that example for negative 1. So to bring this to the actual IDE, as you can see, I'm using Tawny, and you can use idle or any other IDE to write these programs. So here is our variable that holds 3. We check to see if num is greater than 0. If it is, it's going to print num is a positive number. 3 is a positive number. Then it's going to go to the next line. This is always printed. Next, we update num to be negative 1 if num is greater than 0, which is not. It's going to skip this part, and it's going to go to the next line. This is also always printed. So when we run this, we can see the first if, it checks the expression that's true, so it prints num is a positive number, so 3 is a positive number. For the second part, we update that with -1. When it checks this condition, it's false, so it's going to skip this and it's going to go to the next line. So it's going to print this is also always printed. Now, one of the exercises I do in a regular semester, I have an exercise where we would check if John is older than 21 or older than 18. So his age is 21, so we would have age, we assign it 21, and we would check if age is greater than 18, we would print John is older than 18. So in this case, since his age is 21 and 21 is greater than 18, that checks true, then it's going to execute the body of if. Print John is older than 18. Therefore, the program, after we ran it, John is older than 18. So as you can see, if statement, it needs to check for the test expression to be true in order to execute the body of that statement. And to write the if statement in Python, you would start with the keyword if, give it a test expression, make sure that we include the colon, then we would indent for the body of if what you want it to do there, and you can have multiple statements there, then that would complete. So we don't have to have, you know, curly brace like the other programming language. It's pretty simple for Python. Another way that we can write in Python is instead of going into the next line and indent, you can also keep it all on one line. We can say if num is greater than 0 colon, and you can have the body of the if continue in that line, so that way you don't have to go to the next line and indent. If you use another line, you must indent, otherwise it would not know that it is a body of that control statement. So a way that we can do this is we can keep it all in one line and be able to print it. So if I put it onto the second line, it needs to be indented. If I keep it on one line, it just needs to follow the colon like this. Next, I'm going to talk about if-else statement. And in the if-else statement, unlike the if, we actually add the else statement following it, so that would extend it. And earlier we talked about how if would check for the test expression to be true to be able to execute the body of if. Now what if it's not true? Then it's going to go into the else and it's going to execute the body of else. So if it's false, then it's going to kick it over to else and it's going to execute that. So in this, when we look at the diagram, you can see when the test expression is true, it's going to execute the body of if. If it's false, it's going to go to the body of else. And that's how we would be able to apply conditions in our program using if-else. So to look at an example, here's an if-else example. So the first example, I have this program. Num is -5. And if num is greater and equal to 0, we want to print positive or 0. Else, we would print negative number. So we would go ahead and run this program. So let me move this up a little bit so you can see. So as we run it, we would say that since it's -5, it's going to check this condition first. num is not greater than or equal to 0. So is it greater than or equal to 0? No. So this is false in this for this test expression. It's going to skip this line and it's going to go to else because it checked false here. So as it goes to the body of else, it's going to print negative number. And that is because it's -5. Now, if we change this and we make it 5 and we run it, we're going to see that it's going to show positive or 0 because it's checking true for this test expression. Then it's going to print here. And it's going to forget about the else part. But if it's -5, when we run this, since it checked this test expression and it's false, it's going to go to else and it's going to execute the body of else. So we would have negative number. So this is why we would see this in the if-else, and sometimes you would have it nested if-else, if-else, and that will bring us to the next two types of statements. So the next part we're going to talk about if-ELIF-ELSE. And so in Python, unlike the other languages, we have a way that we can implement ELIF-ELSE. So basically it is short for else if. So it's if, else, if, else. That allows us to have multiple expressions in the same. So when we look at this, first it would check for the test expression for the if. If it's false, it's then going to go and do a second check for the second expression here. If it's false, then it's going to go to the else. Now, in the case where if this test expression is true, it's going to execute the if. But if it's false, it's going to go here and check the second test expression. If that is true, then it's going to execute the body of ELIF and forget the rest. But if it's false here, it's going to bring it over to else and execute the body of else. So that allows us to nest in an additional test expression in the case of if-ELIF-ELSE. So let's take a look at that example. In this example, I would have in this example of if-ELIF-ELSE, I have num assigned -5.2. And the first if statement here, I check for num is greater than 0, which it's not. So what will happen is it's going to skip this and it's going to go here to check to see if it's equal to 0, which it's not. It's going to skip this and it's going to go over to else. And it's going to print negative number. So when we run this, we would see that it would show negative number. Now, if I change this to +5.2 and I run it, it's going to automatically check true here and print positive number. If I change this and put it to 0, when I run this, it's going to check false here, skip print positive number, bring it over to ELIF, check this condition. If that's true, it's going to print 0. So here it prints. In the case where we change it to 0, it will print 0. Now if we put it back to -5.2 and we run it again, so you can see it would go to print negative number because it checked false here, it checked false here, so it's going to bring over to the else. So that would be the example of if-ELIF-ELSE. Next, we're going to talk about nested condition for if. So if we would nest the ifs, we can have an if inside another if, where it would check the first condition and then the second condition, and then be able to execute if both of those are true. So in this example, in the nested if example, in this example, we have num, and we're going to ask the user to enter a number as they enter text that needs to be parsed into integer. We want to convert that to a numerical value, so we have to parse it into an integer here, store it into a variable called num, and then we're going to check for the condition. If num is greater than equal to 0, and if num is 0, we would print 0. Else, we would print positive number. Else, on the outside here, we'll print negative number. So let's go through and check this. If this is true, and this is true, it's going to print this. But if this is not true, then it's going to, and this is not true, then it's going to go here, it's going to print positive number. And if this is not true, it's going to print negative number. So what we see is we would have this, else here, and a nested if with the else. So we would have if num is greater than or equal to 0. If that's checked true, then it's going to go in, it's going to continue, it's going to check this, and it's going to print this. If it's not true, it's going to print this. If this is not true, it's going to print this part. And this is not true, it's going to print this part. So we would have a nested if condition. So when we run this, it asks me to enter a number. So let's say if I put in -7, and it would tell me negative number because first condition is not true. Second condition is not true, so it's going to go here. Now let's test it again. And if we put in an 8, so that checks the first condition is true. It's greater than or equal to 0. And this is false, so it's going to go here and it's going to print positive number. Positive number. Now let's check this with the 0. So when we put in 0, this is true. And this is true, so it prints out a 0. So as you can see, we have tested with 3 different types of number, negative, and it checks false here, it checks false here, it prints negative number. When we put in the number 8, it checks true here, it checks false here, so it's going to print this. When we put in a 0, it checks true here, it checks true here, so therefore it prints this. And that is an example of a nested if. Next, I'm going to talk about the for loop in Python. So for the for loop, it's used to iterate over a sequence or a container such as a list, a tuple, a dictionary, a set, or a string. And this is when for loop is used. This is one of my favorite loops to use in all programming languages. So with the for loop, you can execute a set of statements once each of the item in the list is once in each of the item in that list as it iterates. So the example that we see here is we would say for to begin the for loop, and we would use an identifier. Could be a variable. We can say count, we can say I, we can say val in sequence, and so we would continue there. But with Python, you would use the colon, and that would be the statement for the for loop. So the body for the for each of the item in the sequence, it's gonna loop through until the last item is reached. If it's not reached, it's gonna continue to do that until the end of the item in that list. And as it does it each time, it's gonna execute the body in the for until it reaches the end. Once it reaches the end, then it's gonna exit the loop. So let's take a look at the example for the for loop. So in this example, we have a list which names numbers, and we have 6, 5, 3, 8, 4, 2, 5, 4, 11. And we have a variable named total. We declare this variable total, and we would want to initialize it at 0. So what we want to do in this program is we wanted to sum up all of the numbers in that list. And we can do it every single loop. So here we go. So when we run this, we can have it print each time or print the total. So in this case, we're going to print the total, where it's going to take 6, it's going to plus 5, it's going to plus 3, it's going to plus 8, 4, and so forth until the end. And we would have the sum is 48. Now, if we wanted to print this each time it adds it, so if we wanted to print each time that it loops through and add each of the number up, we can add in a print statement there and bring down the total. So what it's going to do is going to take 6, then that's going to be the first round right here. Then it's going to add the next round. It's going to take 6, it's going to plus 5 and put that in total. So now total is 11. Next, it's going to take 6 plus 5 plus 3. It's going to give us 14. So total now is 14. So we're here. And then next, it's going to loop again, 6 plus 5 plus 3 plus 8, which gives us 22, and so forth. So at the end, we would have the sum is 48. So to write our for loop, we would have for, and you can name this anything you want. You can make it I, you can have a count. So in this case, I use val. In, this is a membership operator. So basically, we're saying that val is in numbers in this list, which is an index. So this is basically is an index. So we can change this to I to represent index. That will be better for you to understand. What we would do is for index of each of the element, so we can represent each of the element in that list. We would total each of them, and we would increase it one to the next, to the next, to the next, and so therefore we would have a total to print out at the end. So the for loop, like the if, we would want to have a colon there, and unlike C++ or Java, you don't need an additional parts. You just say for the element that's in that container it's going to iterate through it and be able to add it up. So that's how we would write a for loop. And like the if, you can also have it all in one line without using the second line with the indent for the body of the for. You can find the example and the description of the for loop on the bottom of page 9 going into page 10. Next, I'm going to talk about range function. And range allows you to return the sequence of numbers starting at 0, which is the first index at default. And it will increase it 1 by default unless you specify, and stop at a specific number. So for the range method, we would want to have a start, a stop, and how you want to increase. So the start is optional, but the stop is required. So you can leave this blank and it's going to default to 0, or you can put in an integer where you want it to begin iterate. Then the stop where you want it to end, and the step is optional. So if you leave it blank, it's going to increase by 1. So in this example, we can say that val, this is a variable, val is a range of 3 to 6. And we would use for n in val, print n. So we would loop through it, and then we would print each of the value in that range. So it's going to do 3 and 4 as it stops at 6. 3, 4, 5, and then as it stops at 6. So what you have is you would have a way to implement a range method to be able to start and stop at a specific range. So in this example, I wanted to show you how you can use range to be able to print specific values. So in the first one, as I previously described, so you would have val range 3 from 3 to 6, so it's going to print 3, 4, 5. It's going to stop before 6. Now in the second example, we have vals, and we would have range. We're going to stop at 5, and everything we're going to keep default. So it's going to print 1, 2, 3, 4, and 5. And then for the next, and in this case, we're using a for loop. For C in vals, print C plus 1. And in the next one, we would have num range 0 to 100, and we're going to skip every other. For I in num, we're going to print I. So when we execute this, we would have 0, 2, 4, 6, and so it's going to print all the even number from 0 to 100. So as you can see, you can use the for loop to iterate through a container and also implement the range method to be able to create the range for that particular list. You don't have to have a static list to begin with to be able to print specific values or to be able to access specific value using a for loop. So the details for the for loop, in addition to the while loop, is on page 10 of your notes. So next I'm going to talk about while. So unlike C++, Java, and the other languages, you don't have do while. You simply, in Python, you just have a for loop, a while loop, if, nested if, elif, and if else. So for the while loop, it's used to iterate over a block of code as long as the test expression of the condition is true. So in the while, you would start with simply the key word while, and then you would follow it with the test expression and then the colon. So as it would keep on looping as long as the test expression is true. And as it loops, it would execute the body of the while. It would exit the loop as soon as the test expression is false. So when you look at the diagram here, you can see when the test expression is true, it's going to keep executing the body of while, and so therefore it could be infinitely going as long as it's true. So when do we really use this? We use it when we need to keep prompting the user. Like it would keep on going every single time to be able to enter their name, add memberships, would they like for us to contact them, or reprompt, go back to the beginning, enter the username and password. So it's going to keep on going. Now in the case where if it's false, then it's going to exit the loop and it will just get out of the loop there. So let's take a look at an example in our IDE. So here's the example from our notes. I have the variable n is 8, the total is 0, I is going to be 1. And here we have while I is less than and equal to n, so we can go from 1 to 8. As long as it's less than 1, between 1 and 8, we're going to go ahead and we're going to have it. Total is going to be total plus I. And I is I plus 1. We're going to update the counter. So this is how we would do an increment every time it loops. It counts up. So it's going to have 1, 2, 3, 4, 5, 6, 7, and so forth. So here, when we print, we would have the sum is, and we would add up, and we would bring down the total. So when we run this, we would see that it's 36. So we would have sum is going to be 36, and it would start at 1. So if I add 2 more lines, first I would print the total, then I print the I in the while, then I have 1, 2, 3, 4, 5, 1, 2, that would be total of 3 here, and it's going to print as increment and also the total. Now if I remove this, it simply would just print out the total. When I run this, it would just say sum is 36. It doesn't print out every single count up for the counter or the total. So for the while loop, you can look at the notes on page 11. Next, we're going to talk about break statement. Break statement in Python is very similar to, it's the same as the break statement in other programming languages. It would terminate the loop and it resumes the execution on the next statement. So it would get out of that loop and it forces for the loop to end using the break. And so if you wanted to have it exit, then you would want to include the break statement. So it says that the break statement terminates the loop containing it, controlling the program flows to the statement immediately after the body of the loop. So it's going to go to the next line after the loop. if the break statement is inside the nested loop, a loop inside another loop, then it would terminate the innermost loop and it would continue with the outer loop. And the most common use of this is in some condition that needs to require to exit the loop, so we would use the break statement. So now if you look at the example, that's starting on page 12, and it gives you the diagram on how we would enter the loop. When it tests true, it's going to continue. When it sees the break, it's going to exit the loop. And then it's going to continue to the next part of the program. So to take this into the IDE where we would test the program, so in this program we have a for loop, and inside the for loop we have the if. So in the for loop we have for val in programming, this is a string. If val is I, then we break. So when it gets to the I, it's gonna break and it's gonna print, and then it's gonna exit. Once it exits, it's gonna go to the print the end. So when we run this, you can see it's gonna loop. As we use the for, it's going to iterate. It's going to print the P first, then the R, the O, the G, the R, the A, the M, and it stops at the I. When it gets to the I, it's going to break, and it's going to go to the end. So when it breaks, it's going to print the value at that point. So that will be the M, and it's gonna go to the end. So in this case, the for basically iterates through these characters. We force it to break when it gets to the I, and once it breaks, it's gonna go to the last statement here, where it would print the end. So this is how we would use the break statement. On the next page, page 13 goes over continue statement, which is the opposite of the break. So the continue statement returns the control to the beginning of the loop, and usually we would see this with the while loop. And so as it enters the loop, it's going to test the condition of the test expression here of the loop. If that's true, it's going to go here, and if it sees the continue statement, it's gonna, if it's yes, it's gonna come back to the beginning and retest the expression, and it's gonna keep doing that. Now when it gets to the continue, if it's false, it's gonna exit, and it's going to go to the remaining body of the loop. So what you have is, here is an example so you can see. So here is my for loop. I said for val in programming, if val is I, continue, print val, print the end. Very similar to the break example, but we use continue statement here instead. So when we run this, it would keep going from P. It's going to print P, R, O, G, R, A, M, M. When it gets to the I, as this condition, this test expression is true, when it gets to the I here, what it's going to do is it's going to check true for it, and it's going to go to the continue statement, and then it's going to go to the beginning of the loop again, and it's going to check, and it's going to print the N, the G, and then it's going to get to the end, print the end. So unlike the break, what happens is it's going to skip the I here as it checks for this condition is true. As it sees the continue statement, it's going to iterate through and it's going to print the N, the G, and then it gets to the N where it prints the N as it continues after it prints the G. Okay, so that this is the next line in the program itself. So that shows you the continue statement. That's a little bit different than the break, where the break just exit the program and then go here, where with the continue statement, it's going to come back to the loop again, and it's going to iterate to the next character here and the following character. Once it's finished, then it's going to continue with the program where it prints the N. So you can find the information for the continue statement on page 13 and going into 14. That concludes the part 3 of the lecture, and please watch the video for part 4 for week 2 lecture, which cover lists, tuples, and dictionary.